Okay, so this is lesson 2.1, defining the derivative of a function at a point. And here's, as we continue on with defining the derivative and what calculus is, like for the first part is, the question is, what is the slope at a point P tangent to a curve? So we have this curve here, and we want to know what is the slope of the tangent line at point P. So the tangent line goes through like this. So it only touches it at one point on the curve here. And so what is the slope? That's the question. So how can we define the definition of the derivative? So that's what I'm going to do right now. We're going to define what would be the definition of the derivative. So if I tell you this, that this is point A, whatever input it is, let's just give it a variable of A. And so if this is a function, whatever the function is, f of x, then the output here will be f of A. So that should be good. And what we're gonna do is we're gonna get a secant line, get another point on the graph. Let's say that we get another point on the graph here, and then connect the 2 points, connect these 2 points, and say that this is a good approximation to what the actual tangent line slope is. But as it is, this is it's a good approximation, but it's not, because the tangent line at point A is different. It's less steep. So if I wanted to get the slope of this line that I just drew, this line, the slope of this line, we can use the slope formula for it, no? And but for what we're doing is called the secant line. So the slope of the secant line, we can go with, we can call it m secant. But let's first figure out what would be the coordinates of this point. All right, and how can I, what would be this value here? And what would be this output here? All right, so what we're gonna do is, we go back to just very basic algebra 1. The slope of a line is what? y2 minus y1, and over the rise over the run, no? Over x2 minus x1, rise over run. And then we're going to take it a step further, and this called that this is a secant line now, because we're trying to, so this is going to become the slope of the secant line for this situation. And now we're going to change these inputs and outputs to what we have here and what I've assigned them to be. So x1, let's call this is point 1. So at point 1 has an x1 value of A, an input of A. So this is going to be A. And y1, the output y, is f of A. Okay, now what would be x2? This is point 2, or here's point 2. And we can call it B. And this would be the output f of B. We could do that. But we can look at it another way. What we can look and say is that if we started at this point A and I move some amount h, it's another variable. H stands for a length from A to this new point here. Then this point here would not be B. Okay, I called it B, but B would be represented by A plus H. Okay, so we're here now, B is represented by A plus H. And so the output now here would be f of A plus H. Okay, so if that is true, then we can substitute in here for x2, which x2 represents B, and B represents A plus H. So this is going to be A plus H, and then we're going to subtract the A. And at the top, the output is f of A plus H minus f of A. So we're getting somewhere. Now, what's going to happen here to get the definition of the derivative is the engine behind everything is the idea and the concept of a limit. And so what I said is the idea is that we're going to get this second point, get closer and closer, closer and closer to the first point. So point P is static, and the second point will move closer and closer and closer, where we're saying that H will get closer to 0, because the difference between them, H, we want that point to get closer and closer and closer to A. That now, this is going to get these 2 points infinitely close to each other, that it will become the slope of the secant line. And that is the big idea of calculus. So what we're going to do is then that the rate of change of the derivative, it's called the derivative, the exact derivative at point P, is going to be equal to this limit as H approaches 0 of this quotient that we're saying is f of A plus H minus f of A plus H minus A, where H is going to get closer and closer to 0, that it essentially becomes 0. So, well, as it is, we're going to cancel this out. The A minus A will cancel out. And then we're going to have that it will equal to the limit as H approaches 0 of f of A plus H minus f of A over H as H approaches 0. But it cannot be 0. The problem is that if it is 0, then it would all break down. So it's the limit as H approaches 0, but not being 0. And that would be the derivative at point A. And that would be f prime of A. And this is what the derivative is. And that gives you the derivative at a point. Okay, so let's do this again. So you got a second point, you got point P, you got a second point. You want to make that point get closer and closer to P. We're going to do the average rate of change formula, which is the slope formula. And we get the second point get closer and closer to the point P, and we get the tangent line. And that is the definition of the derivative, one of the definitions of the derivative. There's a second definition of the derivative. The second definition of the derivative is if we do get 2 points, and this is much easier to understand, I think, because it's less steps. Let's say you have 2 points, and let's just call the second point, for not using too many variables, let's just use that variable is x. Whatever this number is just x. And then the output for that is going to be f of x. That's even an easier way to look at it. And what we're going to do is, again, make this point get closer and closer to A. So then x is going to get closer and closer to A, basically. So this, whatever this x value, we want that x value to get closer and closer to A, not equal A. So what we're going to do here, we're still going to use the slope formula, or what was it that we had called it? Yeah, let's call it m secant, the slope secant, because this would be the slope secant again. And so now we're going to use m secant is going to be where our, we have, let's go with our, going back to algebra 1, we got x2 minus x1, and we got y2 minus y1, and then we substitute in, jump into a little more function notations. We're calling this point 1. Point 1 is A. So this is A, this is f of A. And our second point, x2, is going to be, this is our point 2, and our x2 value is x. So we're going to just call it x. And then minus, and then f of x. But that's the secant. And we're just gonna put on that limiting idea of having the x get closer and closer to a. So now the derivative will be then at that point, okay, f prime at a will equal to the limit. Here's again, this is the big thing of limit as x, the x value approaching a. X is approaching a. X approaching a of this quotient f of x minus f of a, x minus a. This is the second definition of the derivative. There's two definitions of the derivative that we gotta go over. Okay, so now how do we put this into practice? Problem 1. Find an equation of the tangent line to the graph of f of x equals square root of x at the point 4, 2. Okay, so in doing calculus, trigonometry and pre-calc is very important. If you have a solid foundation of pre-calc, then calculus becomes much easier to do. Square root of x. Square root of x is just a radical function, and the radical function goes like this. Okay, you should know what it looks like. All right. So this is x and this is y. And so we want to know what is the equation of the tangent line to the graph of f of x equals square root of x at the point 4, 2. So x is 1, 2, 3, 4, and then y is 1, 2. So here. And what is the equation of this tangent line to this curve here? That's the question. Okay, so we want the equation of the tangent line. We already have we need a point. To write an equation of tangent line to any curve, you need a point on the graph, and you need a slope. Okay, well we have a point. And the point is what, 4, 2? But we don't have the slope. And well, that's what we're going to do. That's calculus. That's what we're going to do to figure out what the slope is. And so we can go ahead and plug it into the point slope formula that I told you we need to know. Y minus y1 equals x minus x1. So this is our point 1. And our values for point 1 is that we have x1, y1. And that's what we're going to plug in here. So we have x here, we got y, and then we're going to plug in our x1, y1. So x1 is 4, and then we got our y1 is y1 is 2. So, and now we got to figure this out again. Okay, and that's what calculus is here. All right. How do we find what the derivative or what the rate of change here? What is the slope here? We're going to use one of the two definitions of the derivative. Let's go ahead and use the second definition. It doesn't matter which one you use. Let's use that f prime at a is equal to, let's use the second definition, is equal to the limit as x approaches a. I'm going to use the second definition of f of x minus f of a over x minus a. All right, we're going to use this definition. So if we want to know what is the rate of change f prime at an input for, this is a, of the function, then we're going to go ahead and do the limit as x approaches a, where a is, what is a? A is 4, no? Okay, and then we're going to go ahead and just plug in the information that we know. F of x, what is f of x? Well, telling you here, f of x is square root of x. Okay, minus f of a, where a is 4. And then we have at the bottom, x minus a is 4. So that's what we have right now. And so we have to do algebra here. We're going to do a lot of algebra. So we have f prime at a, f prime at 4 is going to equal to the limit as x approaches 4 of square root of x minus, what is f of 4? What is the function of 4? Well, if you plug in 4 here and plug in 4 here, the square root of 4 is 2. So the square root of 4 is 2. So we got square root of x minus 2 at the top of this thing, and we got x minus 4. Okay. So you guys remember from limits and what I just said, in a quotient, if we do plug in x is 4 into this fraction, x is 4, 4 minus 4 is 0, we got something that you can't do that. You can't have a 0 at the bottom. We got to get around that problem. So getting around that problem, we got to work with the conjugate. And we did that in pre-calc, multiplying by the conjugate to get rid of this problem at the bottom. So multiply by the conjugate of square root of x minus 2, that will be top and bottom. Square root of x, the conjugate is plus 2, square root of x plus 2, and then we'll do at the bottom what you did at the top, and multiply it out. So now we're going to get equal the limit as x approaches 4, multiply these two at the top, multiply it out, and don't do anything at the bottom because that's kind of the procedure. Square root of x times square root of x is x. Square root of x times 2 is positive 2 square root of x. Then you got minus 2 square root of x. That's the whole point of doing this. They cancel in the middle. And minus 4. At the bottom, leave that alone, I said, x minus 4. And then times square root of x plus 2. The middle cancels out. The middle cancels out. So now we're going to get equal to the limit as x approaches 4 of x minus 4 over x minus 4 times square root of x plus 2. And now you notice that we can cancel out x minus 4 and x minus 4, and now we got the limit as x approaches 4 of 1 over square root of x plus 2. And now we can actually substitute in and have not that problem of dividing by 0. If you plug in 4 into x, that will be square root of 4 is 2. And 2 plus 2 is 4. So now the rate of change is 1/4. So f prime at 4 is 1/4. And if we now that we do know what it is, 1/4 is our slope at this point. So it's a rise up 1 over 1, 2, 3, 4. And that is the slope at that point. And now this is the equation of the tangent line to the graph of this square root function. Okay, as a summary, we want to get that. We already know input and the output, 4 and 2. We need to find the slope. We will use this formula. We do algebra, and we get our slope is 1/4, and we're done. Okay, let's go to 2. The limit represents the derivative of a function y equals f of x at a number a. What is the function f, and what is the value of a? This is the first definition of the derivative. The limit as h approaches 0 of f of a plus h minus f of a over h. And that is the derivative, the rate of change at f at a. F prime at a is equal to that. Alright, so by looking at this, what is f prime at a? And what is a? So you would notice then that the function, these are the more difficult ones to figure out what it would be. So here, maybe this is the function f with an input of a. See, this is what we're looking at, and this is what we need to be looking at. So the function looks to be sine of x. And because the h, this h would just be this h, it would always be there. So our a value has to be pi by 2. Our a value is pi by 2. A equals pi by 2. And our function will be this whole thing, which is sine of where this pi by 2 plus h is actually x. So then we have the function be f of x equals sine x. Yes. And it's the derivative of pi by 2 of the function sine x. How can we do this one? Basically, you got to go back to looking at at this again. So the function has to be e to the x, where the a is this value. So yeah, so the function has to be f of x equals e to the x, the exponential function, where a is equal to -3. Um, 2 plus h, we're going back to what I just said. This is the quicker way to do it. The faster way to do it is this. So it has to be some, this is x, the 2 plus h is represented by x. So it's a quadratic function. It's x squared is equal to f of x. And then we're evaluating to find the derivative at a equals 2. A equals 2. Okay, now let's go to part D. How do we, this is not the same as this definition. You have to be able to recognize between the two definitions. This is the second definition right here, the limit as x approaches a, and you can see it from here, that it would be this one. And the function is given here, and it's much easier. Again, this is much easier because the first part is telling you what the function is. So this has to be the function. So this is f of x, x cubed, evaluated at a equals, where are you going to find the a from? You're going to get it diagonally down here, so it's going to be diagonally 3, so at a equals 3. Okay, that's just the procedure maybe of getting this quicker. So this is, I think this is pretty straightforward. I think this is what we just did in the previous problem 1, where we did this, what's the rate of change at 4, and that would be what the function f of x is going to be equal to square root of x evaluated at 4. So a is equal to 4. Limit as approaches 2 of this function, we're going to go to the function being f of x equals ln x, and it's evaluated at x equal to 2. Or a equal to 2. And that would be it for today. Have a good one.